Okay, so we're looking at more derivatives of logarithms and exponentials. And I am going to, you requested number 6. So let me copy number 6. Okay. All right, so we know why. So this one is a chain rule problem. All right, so you have u is e to the negative x squared. And then you have y is equal to the cosine of u. So du dx, well, anytime you differentiate an exponential, you just get that thing. But chain rule says you have to take the derivative of the exponent. So I need to take the derivative of that. So I need to multiply by negative 2x. So now I know du dx. And I also know dy du is negative sine of u. So therefore dy dx is dy du times du dx. dy du is negative sine u. And du dx is negative 2x e to the minus x squared. So now I'm going to rewrite my answer. dy dx. I have the negative times the negative is going to give me 2x e to the negative x squared times the sine of u, and u is e to the negative x squared. And then I'm done. Now, you could have done that directly. It just depends on how your brain thinks. Some people could have done that directly. So you could have just said dy dx says differentiate cosine, which would give you minus sine of e to the negative x squared. And then you got to do the derivative of what's inside. And the derivative of what's inside is e to the negative x squared times a negative 2x. So you could have done it both ways. But either way, you get 2x e to the negative x squared times the sine of e to the negative x squared. Okay. Ezekiel, where were you lost? Tell me where was the obstacle for you?
I think it's just memorizing the chain rule where I have to multiply the first, the derivative of the first term times the second.
Okay, that's the product rule. Whoa. That's the product rule. That's a completely different rule. There was no product rule in this problem because there are no products of functions. This is a function of a function of a function. So the first thing you do to x is you take minus x squared. Then the function of that is to raise it to the exponent e to the negative x squared. Then the function of that is take the cosine of e to the negative x squared. It is a function of a function of a function, which is why it requires us to do the chain rule two times.
Yeah, that's what I meant, the chain rule, not the product rule.
Okay,
yeah.
Just being careful. I don't want you to confuse you, and I don't want you to confuse the rest of the class. Okay.
Yeah, I'm just going to practice a little more of this one, though.
Okay. Is there another one that you had trouble with? We have 3 minutes.
Oh, no, this one was it.
This one was it. Okay, anybody else have any trouble with this? Another problem that they may want to see? Okay. No other questions? Surprise, nobody asked to see number 10 or number 4. Okay.
I'd like to see number 10.
Number 10.
Yes, please.
Okay, sine of x to the x. Okay. All right, so y, number 10, this is another one we're going to do some logarithmic differentiation. So number 10 is y is equal to the sine of x raised to the x power. So I don't know what to do with that. So the only thing I can do is to try to take the log of it and get the x out of the exponent. So I get the log of y is the log of the sine of x to the x. And if you remember, the log of a to the b is b log a. Bring that b down. Okay, bring it down. All right, so let's bring that x down. So we get the log of y is equal to x times the log of the sine of x. Now it's simplified. I can't do anything else with it except take the derivative of both sides. So the derivative of the log of y, remember, is 1 over y. Got 1 minute. Is 1 over y dy dx. And so now I'm going to get the derivative of the first, which is 1, times the second, which is the log of the sine of x, plus the first, which is x, times the derivative of the second. So I'm taking the log of sine. That means sine goes in the basement. And its derivative goes in the top. Okay, so that is what I get. But I'm trying to solve for this. So I have to multiply by y. So now when I get that, I get dy dx is equal to this whole thing, the log of the sine of x, plus x cosine x over sine of x. And that gets multiplied by y. But I know y. So now I get dy dx is equal to natural log of the sine of x plus x cosine x over sine of x. And then I multiply by y, which is sine of x raised to the x power. So this right here logarithmic differentiation. Okay.
Thank you.
All right, no problem. I will upload these as soon as they are available.